to demonstrate the use of the quadratic formula to solve a second-degree polynomial equation. Again, the quadratic formula solves equations of the form x squared plus bx plus c equals 0, and those solutions are given by those coefficients using the following expression. So we can use those coefficients in this formula to find values of x which make the equation true. Let's use it on 3x squared plus 5x minus 11 equals 0. Clearly it's a second degree polynomial equation, so we're using the quadratic formula to solve a quadratic equation. I'm going to be very careful about plugging values into this formula, and I'm going to actually list each of the coefficients explicitly over here, and then I'm going to be very careful about plugging them in. Negative b would be negative 5 plus or minus the square root of, and I'm going to put parentheses around each of my coefficients when I plug in the numerical value, just to be sure when I look at it that I plugged in the correct values. Okay, now I'll do some arithmetic. Times 11, sure, 132. Okay, a little bit more. Again, we're just doing some arithmetic. 157 over 6. And so we have two values for the solution of that quadratic equation. Before I provide the answer, I'm going to try and consider 157 for whether or not it's any squares divide it. I don't think any do. No. So, now we have two solutions to the quadratic formula. Again, we carefully read off the coefficients and plug them into our formula for the solution, and we try to simplify as much as possible.